Okay, so one of the problems that was asked this morning to be demonstrated was number 11. And this is a good old ACT problem. And on number 11, we're supposed to, let's see, what is the area in square coordinate units, that just means units squared, of the parallelogram. So what we need, we know area of a parallelogram is base times height. And so in this case, this is our base here, and we know if we start at 0, 0 and we go to 10, 0, that distance will be 10. We also know our height would be over here. It would be perpendicular to our base. You could even draw it in here if you wanted to. It doesn't matter. Either way, what you're looking for is the difference between your y coordinates. That's going to tell you this vertical distance here. So if this guy's at 6 and this guy's at 0, if I subtract the two, the vertical distance will be 6. So base times height, 10 times 6 would be 60 units squared. So my answer is G as in goat. Okay, the next one that was asked about in class was number 14. This one said find the area. We know this is a triangle, so we're going to say 1/2 base times height. So we know this number here. First of all, we know these altitudes are the sides of our triangle. The base and the height are the sides, and it technically doesn't matter who you call base and who you call height, but these are the two sides that I need. So I'm going to call the 8 my base, so that's 1/2 times 8 times height, and I don't know this guy over here. So what I do know is this 33 on the inside, in which case this would be my opposite side and my adjacent side. So we don't know, is that sine, cosine, or tan? When you use opposite and adjacent, that would be tan. So I'm going to go over here to my side work. So tangent of 33 equals opposite, which is x, over adjacent, which is 8. So then I'm going to go to my calculator. Tangent of 33. Whoa. I'm in radian mode. Give me just a second. Let's try that again. Tangent of 33 is 0.6494. Dot, dot, dot. And then I'm going to put that over 1. I'm going to cross multiply. So I'm going to multiply that number times 8, which gives me my height to be 5.1952. So 1/2 base times height would be 1/2. In my calculator, I'm typing in 0.5, same thing as 1/2, times 8 times that 5.1952 gives me an answer of 20.78. So I'm going to call that 20.8 to the nearest units. Ms. Benton didn't specify units, so we can just call that units squared. The next one we're going to do is number 15. And this is another good ACT problem. To think about this, what I did is I thought about what if I were to bust this up into a bunch of rectangles. I'm looking for the perimeter. We're not going to actually find the area of this figure. Sorry to disappoint you. And so assume that they're all right angles and all the lengths are given in inches. So if I'm going to find the perimeter, I'm going to start here. Perimeter is the distance around the outside. So perimeter equals the 26 plus, okay, if I bust this up into a rectangle, this would be 4 plus 6 plus, and then this is where it gets interesting because I have no idea what that value is there in yellow, but what I do know is that that would be 4 and that this would be 6. So I'm going to go ahead and say plus 10 plus, going across the top, 10 plus 4. I'm going to come down here because I'm running out of room, plus Now it's interesting again. We don't know this piece and we don't know this piece. And there's no way to even figure it out because we don't know these measurements down here. What we do know, however, is that from here to here is 10 because it's 10 up here. And from here to here is 6 because it's 6 right here. So combine these two are 16. So if I do 26 minus 16, the remainder down here has to be 10. So it doesn't technically matter if this is 2 and 8 or 3 and 7 or whatever, because we're adding them all together and order doesn't matter in multiplication anyway. So I'm just going to call both those green ones together 10. And then I've got the 6 plus the 4. And we add all of those up. And I get 80 units, inches, I guess. They told us it was inches. Okay, now we're going to fast forward all the way to number 39. Ah, yes, the good old perimeter and area problem. So let's start with, I got a lot of stuff going on in this picture. All right, I'm going to start with the area. I know that's actually part B, but I already have it worked out over here to the side. So let's look at where Miss Benton came up with these numbers. So first of all, because this is convex, because these things dent outward, that's how I knew I was going to use the add strategy instead of the subtract strategy. So first of all, I bust these up. I cut off all these little pieces. And I made 5 separate shapes. So we've got the inner rectangle. We've got the 2 half circles. We've got the green trapezoid on the left and the purple trapezoid on the right. Okay. As you count these squares, I know it's kind of hard to see across the top, there are 13 squares across the top, and there are 6 squares from the top to the bottom of that yellow rectangle. So to find the area of the yellow rectangle, I just said 13 times 6 to get 78. So there we have that part. Okay, the next thing I did is I have 2 half circles, and I know that 2 halves together, if you were to smush them together, they would make a whole. So that's what I did here. I made 2 half circles equal a whole. I know a whole circle is pi r squared. The only thing I need in this is the r. So r we know is the distance from the center of the circle out to the rim of the circle. We know all the way across the circle, the diameter is 1, 2, 3, 4. And so one way you can think of it is the radius is always half the diameter. So half of 4 would be 2. So that's why I said pi 2 squared, which came out to be approximately 12.56. Okay, then we did the green trapezoid. The 2 bases, the 2 sides that were going the same direction, those are our base 1 and base 2, are 3 and 1, 2, 3, 4, 5. So I had 3 plus 5 over 2 because that's the formula. All times the height. We know the height is the distance between the bases. So the distance between that 3 and that 5 is a distance of 2. So 3 plus 5 is 8. 8 divided by 2 is 4. 4 times 2 is 8. So that's how I got 8 for the green trapezoid. Okay, and then for the purple trapezoid, same idea as the green trapezoid. You have 1, 2 for this base and 6 for the other base. Oh my, did I count wrong? 1, 2, 3, 4, 5. Sure enough, it's 6, Miss Benton. 6 plus 2, which gives us 8. 8 divided by 2 is 4. 4 times 2 is going to be 8. So this comes out to 106.6. My bad. when you add all of those together. Okay, so that is the area. So for my area question, did the assessor calculate the area correctly? I calculated 106.6. The assessor calculated 104. Did he count it correctly? No, because my answer was 106.6. Okay, and then the last thing we're going to do here is perimeter, now that we have all the areas. So let's go around and count everything that we haven't already counted that's just like a flat side. We know perimeter is the distance around the outside, so we're just going to count 1, 2, 3 there. This is 1, 2 here. This is 1 here. I think that's all the distances that are perfectly horizontal or vertical. Okay, next let's address the semicircles, the 2 half circles. Again, 2 half circles together, the distance around those together would be the distance around 1 whole circle. So I know the whole circle is going to be 2 pi r is the formula for that. Again, we discovered earlier that my radius was 2, so I'm going to call that 2 pi 2 for the 2 blue semicircles. Okay, and then the last thing is I have 4 slanty pieces here. 1, 2, oh, I guess I just have 3, my bad. 3. And all 3 of these, we know that to count slanty things, we do the Pythagorean theorem. Right, so this is 2 and 2. This triangle is also 2 and 2, and this triangle is also conveniently 2 and 2. So when we go over here to the Pythagorean theorem, 2 squared plus 2 squared, that's 4 plus 4, so that comes out to square root 8. So all 4 of those, I keep saying 4, all 3 of those are going to be square root 8. And then it's just a matter of adding up everything all the way around. So 3 plus 2 plus, I went ahead and combined the 2 pi r for both, plus this 3 plus this 2, plus a square root 8, plus a 2, plus a square root 8, plus a 13, plus a square root 8. And that's the whole shebang. And it looks like I got 131.6. Just checking my math here, my calculations. No, that's not even close, Miss Benton. I have no idea how I got that number. How about 46.1? It's 46.05, so I'm going to call that 46.1 approximately. The assessor calculated 43, so is that correct? No, because the answer is 46.1 feet. All right, so good luck on the test, guys. I'll see you soon. Bye.